All right, we've talked about looking at similar figures to determine if two figures are similar. Then we covered indirect measurement, where if a side is missing, what does it take to solve for the side? The next thing we're going to do is actually applying scale factor. Now, this is the big focus of the unit. The things we've been doing up to this point were a build up to this. But applying scale factor fits into problems like this. A toy model of a 200-foot dinosaur is 3 inches long. How many times as long as the model is the dinosaur? Well, you think of the fact our new figure is only 3 inches. Oops, let me switch the pencil. New figure is only 3 inches, but our original was 200. We take the new and we compare it to the old. Well, just simplifying that down, we can actually find the ratio, the comparison about the size of the figures, converting one from the other. And then we just take the inverse of it to find the opposite effect. So for this, we're going to learn to understand the ratios and proportions in scale drawings and learn to use ratios and proportions with scales. So we're actually going to be able to tell what are the scale factors of this figure, what would a new figure size be, and also the ability to actually draw that figure based on the scale factor. Now, common places you'll see scale factors are things like models. We talk about scale factor on a road map. When it says 1 inch is equivalent to 3 miles, we can see that as a scale factor. That's a change that is a rate. So a scale drawing is a proportional two-dimensional drawing of an object. Its dimensions are related to the dimensions of the actual object by a ratio called the scale factor, which is our focus point. For example, if a drawing of a building has a scale factor of 1/87th, this means that each dimension of the drawing is 1/87th of the corresponding dimension of the actual building. So we actually, everything dealing with scale factor is just going to be multiplication. That's all that this is going to take. We're just going to have the ability to multiply. And typically it'll be multiplying by a fraction, a ratio, but we will be multiplying. So the scale model is a proportional three-dimensional model of the object. A scale is a ratio between two sets of measurements, the new and the old, scales that can be used in the same units or different units. A photograph shows a scale drawing of a model train. Take the picture, it's not the actual size of a train, it is a representation, a scale of it. So we'll have our first kind of sample question, and this is just a way of looking at it from a table. We're going to identify the scales of a room and the blueprint of a room. So if you're a contractor, you're an architect, you're the builder, you're going to look at the blueprint of the building and interpret it to size. You're not actually going to have to lay out the actual size of the room, but you're going to have a paper representation of that. And so for this, we can look and see that the length of the room is 144, but the blueprint representation of it is only 18 inches. The width of the room is 108, but the blueprint representation is 13/5. So we can actually look at the dimensions of this and see what the actual scale factor is. So you can think of the blueprint as being the new layout of it. We take the new, wrong one. We take the new over the old. And so we take 18 over 144, and we just simplify it down. And 18 over 144 does become 1/8. A scale factor is always the ratio of the model's dimension to the actual object's dimension. So model over actual. And I keep saying new over old. It's a model that's a new figure over the original, the old. So let's look at another one. Same concept, we have a model aircraft and we have the blueprint. Now, I know we just said the model over the original, but what is the original in this case? The original is the model aircraft. So we're going to take the blueprint length, which is the new. In this case, that is 2. And we also take the model aircraft length, which is 12. Now, I want you to see what happens if I was to actually use the width, the wingspan instead. I would do 3 over 18. So 2/12, well, both these have 2 in the thing, so if I simplify both these down by 2, I get 1/6. For the width, both of them have 3, so if I take 3 out of this, I also get 1/6. So we see the same ratio occurring. This is the scale factor. I'm going to start abbreviating that as SF. Scale factor is equal to 1/6. That's a ratio comparison. It is a sixth of the size. The model aircraft is 6 times the size of the blueprint. You can see the inverse there. All right. So I'm going to put up a problem I want us to kind of try out. I want you to look at this first, and I want you to do this, and work's done for you, but I do want you to copy this down as an example. A photograph was enlarged and made into a poster. The poster is 20.5 inches by 36 inches. The scale factor is 5/1. Find the actual size of the photo. So this is letting us figure out what another part of it is by using the scale factor. So the scale factor is 5/1. The original thing was the photo, so that's our old, and the new is the poster, and we're establishing that the ratio was 5/1. Well, in this case, well, how many inches was this? The poster was 36 over a given length, the new over old. So the poster is 36 inches in length. Well, what was the actual photo in length? Well, we don't know, but we can do this 5/1, and this is just like indirect measurement from this point on. It's cross multiplication. We'll make that look more like an L because it kind of looks like a 1. Sorry. So cross multiply, and I get 1 times 36 gives me 36. And I want to do L times 5, and that gives me 5L. And so I simply divide both sides by 5, and L will equal 7.2 inches. All right, that gave me the length of the photo. I can do the same principle for the width. So you can look at this problem. I'm not going to go over it because it is the exact same thing as the length. But for these, you would have to calculate both the length and the width for the photo. So if you want to look at this for a while, you can pause, but I am going to move forward. And we're going to apply the same principle here. So I want to see if you can't set up for both the width and the length. So Mary's father made her a dollhouse, which was modeled after the blueprint of their home. The blueprint is 24 inches by 45. So keep in mind, what are we doing? We're creating a dollhouse from the original. What was the original? The original was 24 by 45. The scale factor is 1.5. Find the size of the dollhouse. So the blueprint was the original. So I have originally 24 and originally 45. And so this is going to be my length. This is my width. And what is my ratio? My ratio is 1.5 over 1, 1.5 over 1. And notice the ratios are flipped from what it was last time because we have our new figure is the dollhouse and the original was the blueprint. All right, once again, you cross multiply. 24 times 1.5. And in this case, we're going to do 45 times 1.5. So that's 1.5, so we'll have L equals 36 inches. And W equals 45 plus half. We'll have to do that. 45 times 1.5. Is 67.5 inches. So that would be the dimensions of our dollhouse. Okay, moving on. You see the same principle. Sorry, this is a repeat of the same problem. Distance on the road map. If you would, pause this and see if you can give this a shot. Bring this in to class next time. And this will be how we'll start as doing an example of these. This is a very similar problem. I want you to do the same thing on. So pause, and I want you to solve this one. Now, we'll discuss the following problems in class, but I wanted you to look at some of these different types of questions. You can pause on each of these and just kind of look through. But you can see there are several different possibilities for actually applying scale factor. Now, we do need to do one about drawing scale factor, and we'll have another video lesson on that as well. So at this time, if you would, make sure you remember to bring in those 2 example problems, and thank you for your time.